Alright, so this is do now number 7. For number 1, you have to complete the other half of the graph, knowing that it is an odd function. Okay, so remember, for odd functions, it's symmetric with respect to the origin. And for example, for every xy in the graph, there has to be a negative x, negative y. So here I see the point 1, negative 2. So that means that the point negative 1, positive 2 has to also be on the graph. So that would be about here. And then here I see the point, it's about 1.75, 0. So that means that negative 1.750 has to be on the graph also. So that would be about right here. Okay, so you just connect the points, and 0, 0, of course, is 0, 0. So we start at 0, 0, and curve it up, and come back down. Something like that. So that's part A. Part B, identify open intervals. So here, remember, it says open, so you're going to use parentheses on the intervals where the function is increasing. So it's increasing. Remember, you read a graph from left to right. So it's increasing here to here, and then increasing again here to here. So it's increasing from negative infinity to negative, this is negative 1 right here, to negative 1. And this is positive 1 right here. So from 1 to infinity. It's decreasing. That means the graph is going down from left to right. So that would be from here all the way to here. So that would be from negative 1 to 1. And then constant, there is no constant. For part C, find any relative max, relative min. So relative max would be up here. And the value of the relative, oh, I did min max first. So the relative max, the value would be positive 2. And then the relative min, that would be down here. The value would be negative 2. Alright, for the domain of 2a, with a rational function, you have to always look at both the numerator and denominator. And in this case, I see in the denominator we have an x. So you guys know that this x plus 5 could never equal 0. So I set up x plus 5 cannot be 0. So then that means that x cannot be negative 5. In the numerator, I have a radical, a square root. So again, that one tells you that 2 minus x has to be greater than or equal to 0, because you cannot have negatives inside a square root. So you set up 2 minus x greater than or equal to 0, so that means that negative x is greater or equal to negative 2. And positive x, you multiply by a negative. Remember, when you multiply an inequality by a negative, you switch the direction, is less than 2. So I have to take this and this into account, both of them together. And like I said in class, I like to draw a number line. I put the numbers in the order, so negative 5 and 2, that's how they appear on a number line. I know that x cannot be negative 5, so I'm going to put an open dot right here on negative 5. And I also know that x is less than or equal to 2, so I'm going to put a closed dot right here and go to the left because that's less than 2, this way. So the combination of the two restrictions is on the number line. So the domain would be from negative infinity to negative 5, parentheses on the negative 5 because it does not include it, union with negative 5 to 2, bracket on the 2, and parentheses on the negative 5. Okay, so this is a domain for A. For B, x is not in a denominator and x is not inside an even indexed radical. So that means the domain is all reals. No restrictions on the domain here. Alright, so for this piecewise function, first thing I'm going to do is add the boundary lines, the ones that separate the different pieces of the graph. And where I get those boundary lines is by looking at the domain right here. So I look at all the numbers in the domain. There's a -2, +2, and a +8. So that's where my lines are going to go. And they're going to be vertical dotted lines. So here's one, a negative, x equals -2, x equals +2, and x equals 8. Okay, next thing is I'm going to find the boundary points. So starting off with the first piece right here, the boundary point is at x -2. So when x is -2, it's going to be an open dot because it's less than, not less than or equal to. And you're going to put -2, and the y value is this one right here, 4. Okay, then we have, move on to the next piece right here, the second line right here. The domain tells you that x is between -2 and +2, so I'm going to replace this x right here with -2 first. And it's going to be a closed dot because it's equal to. So -2, and then replace the x with -2, that gives you -4 plus 3 is -1. Then the next point, the other endpoint would be this one. Again, we put a 2 there, and so that gives, and it's another closed dot, so you would get +2, and you would also get -1. For the third piece, this line right here, it goes from 2 to 8, and both of the points will be open because there's no equal to in the inequality. So replace the x right here with 2 and then with 8. Okay, so we're going to have open dot, 2 times 2 is 4, 4 minus 5 is -1. And then open dot with 8, 8 times 2 is 16, minus 5 is 11. Okay, so now I'm going to plot the different points. Remember, this part right here is 4. This part right here is -x² plus 3, and this part right here is 2x minus 5. Okay, so on the first part, starting with -2, 4, let me use a different color. -2, 4 is going to be an open dot. The equation is y equals 4. It's a horizontal line, but I could only go to the left of -2, so it's going to go this way. Okay, and then for the middle section right here, the -x² plus 3, I'm going to start off with 2 closed dots, -2, -1, and +2, -1. And I know it's a parabola that opens down, so I pick another point. 0 would be an easy one. -0² plus 3 gives me 3. And so I connect the points. Remember, it's not a V shape, it's a U shape. So make it curve, a little bit curvy, because it's a parabola. And then for the third piece, I do my 2 open dots at 2, -1. Now notice there's already a point at 2, -1, and it's closed. So you don't have to draw a bigger open dot because, you know, it's already filled, so that's okay. And then you go to 8, 11. I'm going to go right here, right in that section. That's 8, 11. And the slope of that line is 2, so if you want to just use a ruler and connect the 2 points, that's fine. Or from here, just go up to over 1. And up to over 1, up to over 1, up to over 1, up to over 1, up to over 1. Okay, so I think I'll do that because I can't use a ruler with this. So I'll just put the dots right here so that the line could come out straighter, and then connect them. Oops, I made a mistake. The dot over here, I made it closed dot, huh? Should be, redo that, should be an open dot. Okay, so now we do the domain and range. So domain, you go from left to right, we're going this way, and so you see points from negative infinity all the way to 8. And it doesn't include 8 because it's an open dot at 811, so we use parentheses. And for the range, we go from the bottom to the top. So the first point that we see at the bottom, the lowest point on the graph, is this one and this one, right? So it's at -1. And it's a bracket because it includes the -1. And then you keep, you go up, 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 up. Even though it stops here, this part continues. And it ends right here. So this is the highest point on the graph. It's an open dot, so we're going to use 11, but with a parentheses.